The banking industry thrives on trust, accuracy, and efficiency. In today's fast-paced world, these pillars are increasingly reliant on robust software systems. From online banking to complex financial transactions, software development has become the heart of modern banking operations. This essay delves into the crucial aspects of software development within the banking sector, emphasizing best practices, essential skills, and the importance of a collaborative approach. Modern banking relies on complex software systems that handle vast amounts of data and facilitate a wide range of transactions. Customers expect seamless online and mobile banking experiences, while banks rely on software for risk management, fraud detection, and regulatory compliance. Therefore, effective software development is not just an option, it's a necessity for survival and success in the competitive financial landscape. The journey of developing banking software begins with a clear understanding of the business needs. This initial phase, known as business area analysis, involves close collaboration with stakeholders to identify pain points, define objectives, and outline the scope of the project. For instance, a bank might aim to improve its mobile banking app to offer a more user-friendly interface for managing investments. Once the business needs are understood, the next step is requirements definition. This phase translates the business goals into specific, measurable, achievable, relevant, and time-bound, smart software requirements. These requirements serve as the blueprint for the development process, guiding the design, coding, and testing phases. Continuing with our mobile banking example, a requirement could be to enable users to view their investment portfolio in real time with a single click. With the requirements in place, the design phase kicks off. Here, software architects and developers create a detailed plan of the software's structure, components, and interactions. This blueprint ensures that the software is built on a solid foundation and can meet the defined requirements. In the mobile banking app scenario, the design phase would involve creating wireframes and mock-ups of the new investment management interface, detailing user flows and data interactions. Throughout these initial phases, effective communication is key. Regular meetings, clear documentation, and the use of visual aids help ensure that all stakeholders are on the same page and that the project stays aligned with the business objectives. By investing time and effort in these early stages, banks can minimize costly rework later in the development lifecycle and pave the way for a successful software project. The design phase lays the groundwork for the actual construction of the software, which involves coding, testing, and deployment. In this phase, skilled developers translate the design specifications into lines of code, using programming languages like Java, Python, or C++. They adhere to coding standards and best practices to ensure the software's readability, maintainability, and efficiency. As the code base grows, rigorous testing becomes essential to identify and rectify any defects. Different testing levels are employed, including unit testing, testing individual components, integration testing, testing how components interact, and system testing, testing the entire system. Automated testing tools play a crucial role in this process, enabling efficient and repeatable testing cycles. Once the software passes all the necessary tests, it's time for deployment. This involves transferring the software from the development environment to the production environment, where it becomes accessible to end users. Deployment strategies vary depending on the complexity and scale of the software, with options ranging from traditional on-premise installations to cloud-based deployments using platforms like AWS or Azure. Throughout the coding, testing, and deployment phases, close collaboration between developers, testers, and operations teams is crucial. This collaborative approach, often referred to as DevOps, development and operations, fosters a shared responsibility for the software's quality and ensures a smooth transition from development to production. By embracing automation and continuous integration, continuous delivery, CI/CD practices, banks can accelerate the software development lifecycle while maintaining high standards of quality and reliability. Section 4. The foundation, infrastructure, and design patterns. Behind every successful software application lies a robust and well-designed infrastructure. In the banking sector, this infrastructure encompasses the hardware, software, and networks that support the software applications. Scalability, security, and reliability are paramount considerations in infrastructure design for banking systems. Cloud computing has revolutionized infrastructure management in recent years, offering banks flexible and cost-effective solutions. By leveraging cloud platforms like AWS, Azure, or Google Cloud, banks can scale their infrastructure up or down based on demand, paying only for the resources they use. Cloud providers also offer a wide range of managed services, reducing the burden on in-house IT teams. Design patterns play a crucial role in building maintainable and scalable software systems. These are proven solutions to common software design problems, providing a reusable template for developers. For instance, the Model View Controller, or MVC, pattern separates the application logic from the user interface, making the software easier to modify and extend. Similarly, the singleton pattern ensures that only one instance of a particular object exists, which is useful for managing shared resources. Choosing the right infrastructure and design patterns is essential for building banking software that can stand the test of time. Banks need to carefully consider their specific requirements, such as transaction volume, data storage needs, and security standards when making these decisions. By investing in a solid foundation, banks can ensure that their software systems are reliable, scalable, and adaptable to future growth and changing business needs. Section 5, Bridging the Gap: Domain Knowledge and Future-Proofing. While technical skills are undeniably crucial in software development, domain knowledge is equally important, especially in a specialized field like banking. Developers who understand the intricacies of financial products, regulations, and business processes are better equipped to create software that meets the specific needs of the banking industry. For instance, a developer working on a loan origination system needs to understand the different types of loans, credit scoring algorithms, and regulatory requirements related to lending. Similarly, a developer working on a fraud detection system needs to be familiar with common fraud patterns, data analysis techniques, and risk management principles. The banking landscape is constantly evolving, driven by technological advancements, changing customer expectations, and new regulations. Therefore, it's essential to build software that is not only functional today, but also adaptable to future changes. This requires adopting a forward-thinking approach and embracing technologies that promote agility and scalability. For instance, banks are increasingly incorporating artificial intelligence and machine learning into their systems to automate tasks, improve decision-making, and enhance customer experiences. Similarly, blockchain technology is gaining traction for its potential to streamline payments, enhance security, and reduce fraud. By staying abreast of emerging technologies and incorporating them strategically, banks can future-proof their software systems and maintain a competitive edge in the ever-evolving financial landscape. Section 6. The power of teamwork, collaboration, and support. Software development is rarely a solo endeavor, especially in the context of large, complex systems found in the banking sector. Successful software development requires seamless collaboration among various stakeholders, including business analysts, developers, testers, project managers, and operations teams. Effective communication channels are vital for fostering collaboration. Regular meetings, both formal and informal, provide a platform for sharing updates, discussing challenges, and making collective decisions. Tools like project management software, version control systems, and online communication platforms facilitate information sharing and streamline workflows. Once the software is deployed, ongoing support and maintenance are crucial to ensure its continued functionality and address any issues that arise. This involves monitoring system performance, applying software updates, and providing technical assistance to end users. Banks often establish dedicated support teams or outsource these functions to specialized service providers. A positive and supportive work environment is essential for fostering creativity, innovation, and productivity within the development team. Recognizing and rewarding achievements, providing opportunities for professional development, and cultivating a culture of continuous learning contribute to a motivated and engaged team. By investing in their people, banks can create a thriving environment that attracts and retains top talent, ultimately leading to the development of high-quality software systems.